Welcome fellow learners. Microsoft has recently released Florence-2, which is an advanced vision language model. Existing vision model excels in transfer learning, but they struggle to perform diversity of tasks. This Florence-2 model tries to solve that problem by simply passing simple text prompts to it. So this Florence-2 model can do diversity of tasks like image captioning, object detection, segmentation, and even OCR. So if we go through technical report of this Florence-2 model, we can find out its architecture in this paper. So we can see our input will be the image plus the corresponding text prompt, like what does the image describe. This could be our one of the text prompt. Those input will be first converted into embeddings and then it will be passed to a transformer model. Transformer model consists of both encoders and decoders, and after this we will be getting our output. Our output could be either text only, or we could also be having text plus location tokens of those particular objects. So like we can either get text output as this, or we can get text like person plus its location tokens like these. What is the location of this person in that image? So this is pretty much gist about architecture of this Florence-2 model. This Florence-2 model comes in basically two varieties. One is pre-trained model that comes with either 0.23 billion parameter or 0.77 billion parameter. And other one is basically fine-tuned model. This is also of the same size, either 0.23 billion or 0.77 billion. But this is fine-tuned on collection of downstream tasks. So let's directly jump into the implementation of this Florence-2 model. We will be using this Florence-2 large fine-tuned model, this one. And we will be implementing this model in our Google Colab. So let's start. In this notebook, we are going to implement OCR using this Florence-2 Vision Language Model. So let's first connect to a GPU server. We are going to use a free GPU available in this Google Colab, and that is basically T4. And next, let's install all the required libraries. So we will be installing this flash attention, TIM, Accelerate, and EINOPS. All other basic libraries like transformer and all, those are already installed in this notebook. So you might be wondering how we can use this flash attention in this T4 with this T4 GPU. So recently, the people who have worked on this flash attention part, they have made it work to use this flash attention with T4 and RTX kind of GPUs also. So apart from using it with A100 and H100 type of GPUs like Ampere based GPUs, we can also use this flash attention with T4 and RTX kind of GPUs. And other libraries are like this TIM is being used as a PyTorch image model library. This will be used with this Florence-2 model. This Accelerate will be used whenever we are passing this parameter device map equals to CUDA, whenever we are loading this model and then passing this parameter. So in that part, this Accelerate library will be used. This EINOPS library will be used to basically perform better tensor operations. So this might take a while, and once this installation process is being done, we need to restart this basically current notebook such that all installation takes effect and we can smoothly run our this Florence-2 model. Now you can see all the required libraries are being installed. So let's restart this session, and once we have restarted this session, we will be having all the libraries that we required. So in the next part, let's import our Florence-2 model from Hugging Face that we have seen earlier from here. So for that part, let's first create a folder where we are going to basically save our model. Now we can directly use auto model for causal LM and auto processor to import both model and processor from this Hugging Face library. So you might be seeing few of the parameters that I am passing over here. The first one is basically the model name that I have copied it from here. This Microsoft Florence-2 large FT, which is abbreviation for the fine tuning. Cache DIR I have passed as basically I want to save this model to particular this folder which I have created earlier. And the third one is device map CUDA to make sure that my model runs on GPU server. And the final one is basically trust remote code. So like whenever we are installing this Florence-2 model, this might be running some code which is basically fetched from this Hugging Face directly. So we need to pass this parameter as true over here. Another one is this processor. So this is the processor where which we will be using for either processing the input or processing the output from this Florence-2 model. So this processor consists of both image processor and the text processor both. So once we have done that, now we are having both model and processor with us. And if we see details of this model, you can see this model is only of around 1.54 GB. And we have already seen this model consists of only 0.77 billion parameters. You can see over here. So this is pretty small model as compared to the other large language model or other basically you can say multi-model like Phi 3 and all. So in the next part, let's import an input image which we are going to use and test out this model. So this is basically an image which consists of an invoice. It is having different basically text like total, like bill to, ship to, addresses, and those kind of text written in this particular invoice. So now if we go through this Hugging Face page of this Florence-2 model, they have given us few simple text prompts which we can utilize and pass to this Florence-2 model and get results out of it. Like you can see, we can pass caption to basically work on image captioning. We can pass detailed caption to get much more detailed caption of the image, and then more detailed caption. Similarly, others like we can use OD for the object detection part, and similarly for the OCR part, we can use this OCR prompt. So we can use this OCR prompt, and then along with the image, we can pass this OCR prompt to this particular processor. Once we have passed this to processor, it will basically convert these input to basically the tokens. So like if we print out this inputs, we can see that it will be consist of both text inputs. So you can see at the start, these are the tokens for the text input. And the second one is basically the image is converted into the numbers. So these are basically the pixel values for that image that we have passed. So this is pretty much input that we are going to pass to our model. So in the next part, let's generate output from this model. So like you can see, we have passed input IDs. These are basically the text input. Pixel values, from here you can see these are the pixel values that we are going to pass. This is basically the pixel value of the images. And we are passing max new tokens. Max new tokens are basically the number of maximum tokens that we want this model to generate, not more than that. And the final parameter is basically the beam size, that is basically the 3. So this will be used to sample the prediction. So now this model has run. You can see it has taken very little time. It has taken only 4.59 seconds. And we have our generated IDs. Let's decode that by using the processor that we have imported earlier. And you can see this has given us all the text output that is written in that image. Like it start with the invoice and end with like ease repairing. So you can see like it start from the top like this invoice, and it goes to the bottom also like ease repairing and on. So this is pretty much output that we are getting from this Florence-2 model. One more thing is like we can use OCR with region to basically get the regions where this particular text resides. So like along with the text data, we can also have the bounding boxes of those text data. So let's pass that over here, and let's see how this gives us the result. So let's pass that to our prompt. Now our input will change a little, and then pass those inputs to our model, and it will generate us the output. Once we have that output, let's decode that using this processor, and let's see how does this gives us the result. So you can see it has took only 14 seconds to run this, and in the output you can see a lot of text data like invoice along with their coordinates like LOC underscore 82, LOC under. These are basically x1 y1, x2 y2, and x3 y3, all the values for one particular text data. So this is the bounding box for this invoice. Similarly for this particular one, for this particular text, this is the bounding box that it has given to us. Now if you see this, it is pretty difficult to find out how this particular location that has been given by this Florence-2, how we can basically depict it and find out where does this particular text resides in the image. So for that part, let's basically draw that on image, and let's see how it is basically giving us the output. So similarly, as we have passed this OCR with reason tag, or you can say prompt, to our model, we also need to pass that tag to our this processor, and this will basically run a function which is basically post process generation. This will take the generated text from here, this generated text prompt, which will be basically this OCR with reason, and the image size, and then it will basically gives us the post processed output from this generated text. So let's see how does this gives us result. So this is the result it has given to us. So now you might be wondering, in this part generated text, it has given us this lot of text data. Now when we have done this post process generation, it has given only this two values over here. So like this first one is invoice and second one is John Smith, nothing else. So what could have happened? So what I found out, if we go to this model and if we go to one of the file, so let's go to that file which is being used in this post processing part. So if we go to this processing Florence2.py file, and I have basically gone through this code and found out like they have used a threshold value which is basically making it to filter out all those bounding boxes. So like what they have done, you can see over here. So like they have used a threshold value of 0.01 as area threshold, and if that area threshold is greater than 0, and they have passed that as 0.01, in that case they will basically applying a shoeless formula to filter out all the bounding boxes which are smaller in size. So due to that, it is basically filtering out all the smaller size bounding boxes. So what I will do, I will basically comment out this part of the code, and by commenting it out, we will not be seeing any filtered out bounding boxes. So let's save this file. Okay. One more thing is like let's print that these predicted to text boxes in our image. So for that part, I am using simple code. I am just basically pasting or basically drawing polygons over those images. So if you see in the output, you can see only this box, John Smith. This John Smith text is being given a box, and at the top you can see only invoice is given a box. Now as we have basically changed the code, let's again import both model and processor, and we might only need to import the processor over here. So to import the processor, let's use this path directly. So let's use this path. We need not to basically import it from Hugging Face. So for that part, let's copy this path, and we can pass that path over here. And in that case, we need not to use this cache dir, and we will be having our this processor separately. So this processor will be imported from this local cached directly, and we need not to import it from the, you can say, Hugging Face. So let's run that. Okay, so there might be an error like content my models Florence2 does not appear to have a file name config.json. Okay, so we need to pass this path, not that part, because we need to pass a further downstream path. So let's copy that and pass it over here. Okay, and then run that cell, and now we will be having our processor with us. Once we are having this processor, so let's run that post processing code. Let's run this post processing code. Now you can see we are having all the bounding boxes and all the text that we have seen earlier with this generation from this model. And now we can use our this code where we generate or basically draw boxes over the text data. So you can see now every text has been given a box over these images. So in this way, we can use this Florence-2 model. This is pretty much advanced, you can say, visual language model, which we can utilize to do OCR tasks. And we can see like it has given really good results. It has find out all the text data which are written over here. And similarly, it has given text data to us. And it has also already given a post-processing code which we can apply to get all the bounding boxes along with all the text. You can see these are all the boxes, and along with them, this is the text data that we are having. So this is basically the output that we are getting from the Florence-2. So my suggestion is check it out and let's try out with different text data, or basically scanned PDFs or scanned images, and let's see how does this performs, and comment if you find anything problematic in this particular model, and how does it perform with your PDF or something. So great. Thanks for making till the end of this video. Goodbye until the next time.